In this video, we will be using our knowledge of transformations and parabolas to graph a parabola. So we're going to start off with our parent or most basic parabola, which is y equals x squared. So we're going to start off with a table of values, and I'm going to take all of these x values from -3 to 3, and I'm going to square them. So -3 squared is 9. -2 squared is 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Notice that even the negative x values had a positive y value, because a negative number, when it's squared, it's still positive because negative times negative is positive. Now, let's take these key points and we're going to plot them on our grid. So our first coordinate is -3, 9. Then we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And then you can connect your dots and put arrows at the ends of your parabola because this goes on forever. So this is the parabola y equals x squared. When you're graphing using transformations, you're always going to start off by graphing this parent parabola. And now let's just list our properties for this parabola. The first one is that the parabola opens up. And we already know that if the a value is negative, then our parabola is opening down because we actually have a reflection. The x-intercept of this parabola is at the origin, and so is the y-intercept, and so is the vertex. Now, of course, the minute this parabola starts moving around, these properties will change. The axis of symmetry is the line that cuts the parabola in half, and it is at x equals 0. It's actually this line here, that is the y-axis. And the optimal value is a minimum, because it's opening up, of 0, because that vertex is the lowest possible point. And now our step pattern. We know that the step pattern is 1, 3, 5, 7, etc. I'm just going to show it here. So from the vertex, when I move to the right one, I'm going up 1 to get to my key point. Then to the right one, up 3. Then to the right one, up 5. And that's the step pattern, 1, 3, 5, 7, 9, and it continues. Now here are two more properties that are new to us, and they are things you will see in grade 11, so it's just a little sneak peek to it, and that is domain and range. Domain is the set of all the possible x values that this parabola can have. So you're pretty much asking yourself, what x values can you plug into that equation of y equals x squared? And it can be absolutely anything. And if you look at this parabola, it goes on forever upwards, which means this right side will continue all the way to positive whatever, infinity. I can have a value on this parabola where x is 1,000 or 2,000 or 1,000,000. And same thing with the negative side. This continues forever, so I will have all the negative values. So the way we write that, we want to state that x can be anything. So what we do, we open up these fancy brackets and we write x, this symbol e, which means element of, and we put an r to show real numbers. So I'm going to make a note. E means element of, or it means belongs to. And then r is real numbers, and that just means anything. X can be anything. So x is an element of all real numbers. And this will always be the domain for a parabola because it will always extend forever to the right and to the left. Whether your parabola is opening upwards or downwards, that's a different story. So now we go to the range. And the range is the set of all the possible y values. Now, if you look at this parabola here, there's so much going on here. But if I look below the x-axis, there's nothing. I cannot find my parabola there. So I pretty much want to say that you'll find a y value anywhere above the vertex, so above 0. And that's where that optimal value is important. We have a minimum of 0, which means everything is above 0. So the way we write that is We still started the same way. Y is an element of all real numbers. But then we have to say, but wait, you can't have any negative numbers. Or you want to say y has to be greater than or equal to 0. So y is greater than or equal to 0. So the domain, it's always going to be like this. But the range, this restriction part will change depending on the vertex and if your parabola is opening up or down, meaning there's a max or a min. Now, before we actually go to graphing, let's just refresh on our transformations and then we'll go from there and combine all of these in one. So your a value, we already said if it's negative, it's a reflection over the x-axis. But ignoring the negative, if your a value is greater than 1, you have a vertical stretch. If it's less than 1, it's a vertical compression. Then, inside the bracket for your h value, if it says x minus a number, you're actually shifting to the right. If it says x plus a number, you're moving to the left. And now finally, the number at the end, that's your up-down movement. So if it's positive, you're shifting up. If it's negative, you're shifting down. So let's put this all together now. So for each parabola, we're going to state the transformations and we're going to apply them in the correct order. And this is important. Your a value is applied first because the a value is attached to your bracket by multiplication. It's like BEDMAS. Multiplication comes first. So we apply the stretching or compressing or reflecting, and then we'll do all the shifting because that's an addition subtraction, which is the last step in BEDMAS. And the shifting can all be done in one step. So let's start with the first one. We have y equals negative x minus 6 squared plus 7. So the negative tells me that I have a reflection over the x-axis. The minus 6 tells me I'm actually shifting to the right 6 units. And the plus 7 at the end tells me shift up 7 units. Now before I can do any of these transformations, I have to graph that parent parabola first. So we had the point at 0, 0, 1, 1, 2, 4, 3, 9. So I'm pretty much just squaring all these x values on the spot. The negative 1, 1, negative 2, 4, negative 3, 9. And now I'm going to connect, put arrows at the ends, and I'm going to label this y equals x squared. Now, let's do our first transformation, and it's going to be the reflection over the x-axis. So all of these points here are going to reflect it so that your parabola is now opening down. So let's go ahead and do that. The point at the origin stays where it is, but the point at 1, 1 will now be 1, negative 1. The point that was at 4 will be at negative 4. The point that's at 9 will be at negative 9. And the same thing on the left side. And then we can connect. Now, because all we've done here is the reflection, or that a value, this will be labeled y equals negative x squared. And now we can do all the shifting in one step. If you want to do it in 2 steps, you can. So by that I mean you can shift this blue parabola to the right 6 units, draw it, and then shift up 7 units. But I think it's a little more efficient to do it all at once. But again, your choice. So I'm going to do this in one step. So I'm going to start with my vertex. I'm going to move right 6. 1, 2, 3, 4, 5, 6. And then up 7. 1, 2, 3, 4, 5, 6, 7. And that takes me here. And then I'll do the same to the other points. And that point will take me there. The point on the left will be here. This point that's at 2, negative 4, move it to the right 6, and then up 7. And then I can use my symmetry to get the other point. And then finally, right 6, up 7. And the same on the left. And there we go. And I'll label this as the entire equation. Okay, so the shifting can be done all at once. And you can do a logic check here. Looking at your actual equation, you know that the vertex should be 6, 7, which it is. And you know that the parabola should open down, which it does. And you should actually even know your step pattern, and you can do a little check with that as well. But this is what I would expect. I would expect your A value in one step, your shifting in another. If you want to do more steps, you're more than welcome to. Okay, now let's write our domain and range for that final parabola. The domain is going to be anything. So x is an element of all real numbers because I can plug any value in. There's no restriction. There's nothing stopping me. That parabola will extend forever to the right and left. But now for my range, y can be anything except, if you look at your graph, there is nothing above 7. So I want to state that y has to be less than or equal to 7 because your parabola is opening down and it has a maximum of 7. So y is less than or equal to that optimal value of 7. And there you are. Now, just a few observations I want us to make. When I did my reflection, so when I dealt with that a value, all it did was it changed my y values. The x's, all the points stayed in line. It's just the y values were now the negative version because a was -1. And in terms of your shifting, when I move to the right, that horizontal shift affects my x coordinate now and the y stay. But the vertical, so the shifting up, affects the y's. So just a little observation. Okay, let's go to the next one. So we have y equals -1/2 x squared plus 3. So I want you to pause the video and state the 3 transformations that are occurring here. And I also want you to graph your base or parent parabola on the grid to get ready for the transformations. So pause the video and then come back when you're done. Okay, so looking at the transformations, the negative a value tells us that we're reflecting over the x-axis. The fact that the absolute value of a is 1/2 means that you have a vertical compression by a factor of 1/2, and make sure your communication is good here. And then the plus 3, it is outside, it is after your exponent of 2, so it is the up-down movement, so you're shifting up 3. Now, the reflection and the compression, if you want, you can do it all in one step, okay? Or you can do it in 2 steps. The choice is yours. I'm going to show you in 2 steps in this example, but I'll explain how to do it all at once as well. But the shifting has to be done at the very end. So I drew my parent parabola here. Hopefully yours looks like this as well. So I'm going to start with my reflection. So just like the previous example, I'm going to take all of my coordinates and reflect them so that they are the negative version of the y values. So we should have something like this. Now, I'm going to label this as y equals -x squared because that is all I have done to it. Now I'm going to do the compression, step 2. So I want to take all of these coordinates here and squish them so that they are closer to the x-axis. So I'm going to look at the distance from the point to the x-axis and I'm going to cut it in half. Our first set of points are the ones that are located at -1. So 1, -1, and -1, -1. Their distance from the x-axis is 1 unit. Half of that is 0.5. So I'm going to squish them in right over here at 1, -0.5, and -1, -0.5. Now I'm going to take the coordinates that are at 4. So these 2 coordinates right here, they are 4 units away from the x-axis. Half of that will be 2 because 4 times a half is 2. So I'm going to plot those points. Notice they're still in line though. The x coordinate's the same, it's just the y that's changing. And then finally, these points here are 9 units away from the x-axis, and half of 9 is 4.5. So I'm going to move it to 4.5, and then I'll connect my dots. And the one at the origin is staying where it is. And when I label this one, it is just y equals negative a half x squared, because we've done the reflection and the compression. And now it looks like it's been squished in. Now our final step is shifting up 3. So we take this green parabola that I just drew, and we're going to shift those points up 3. The yellow one is useless to me now. So I'm going to start with my vertex, and I'm going to move up 3 units so that I'm at 0, 3. Then I'll take the points that are at negative a half. So 1, 2, they're going to now be at 2.5. Then I'll take the points that are at negative 2. 1, 2, 3. They're now going to be at 1. And then the points at negative 4.5, 1, 2, 3, will be at negative 1.5. And then again, you can connect the dots, make sure you're putting arrows at the end, and then we can label this as the entire equation. And there it is. So this I did in 3 steps. Like I said, shifting can be done in 1 step, and here we only had 1 type of shift. And you can also do the a value in 1 transformation if you'd like. And I'll show you how to do that now. So I could have gone from this black parabola to the green one in 1 step. And all you have to do, as long as you remember that a vertical transformation affects the y coordinate, you're going to take the y coordinates and multiply them by negative a half. That way you're doing the reflection and the compression all at once. So let's say this point here. It has a y coordinate of 1. Actually, both of these do. 1 times negative a half is negative 0.5. And here it is. That's exactly where I plotted it. Because if I take this and make it negative, I go to negative 1, and then half of that is negative 0.5. Let's look at these 2 points that are 4 units away. 4 times negative a half is negative 2. And boom, that's exactly where we drew them. These points here at positive 9 times negative a half is negative 4.5. And that's exactly where we plotted them. So you can do that in 1 step if you'd like to. All right, using that blue final parabola, let's state the domain and range. The domain is anything, so x is an element of all real numbers. But your range, we have a maximum value of 3. That's what my vertex is. So there's nothing happening above 3. So I'm going to write that as y is an element of all real numbers, but y has to be less than or equal to 3. And there we are. Let's go to our next one. Here we have 3 times x plus 5 squared minus 8. I want you to try this example on your own. So state your 3 transformations, graph the parent parabola, try your stretch, and your shifting. And we'll take it in steps so that you can check your work along the way. I want you to pause the video here, and all I want you to do before you press play again is state the transformations and graph the parent parabola to make sure you're on the right track, and then come back. Okay, so we should have a vertical stretch by a factor of 3. Shift left 5 units. So check that, because that would be a common mistake of people writing right instead of left. And then shift down 8. And here is your parent parabola labeled. Make sure you have labels and make sure you have arrows at the end for good communication. Now, you're going to vertically stretch all of these points by a factor of 3. So you want to triple the distance of each point from the x-axis. Now I'll tell you right now, these points here that are at 9, they're going to go off the page, so you won't be able to do it. But I want you to pause the video and try to stretch these points here so that your parabola gets thinner. So pause and come back. All right, so the point at the vertex, hopefully you have it where it is. The points that are at 1, when I triple them, they should now be 3 units away, so 1, 3 and negative 1, 3. And then the points at 4, when I triple them, I get 12, which That goes off the page as well, but I'll just estimate it to be here and here. So now you can see that the parabola got thinner and it has been stretched vertically. And I will label this as y equals 3x squared. So hopefully you had that, and if you didn't, hopefully you see where you went wrong. So I'm doing that as step 1. And now I'm going to do the shifting all in one step, and that will be my step 2. So again, I want you to pause the video and shift all of these points left 5, down 8, including the ones that we made up that are at 12. Maybe you actually want to extend your grid to show that those are 2 units above your y-axis. So pause and come back. All right, so hopefully this is what your parabola looks like. So I took all of these points and went left 5, down 8. And a little logic check you can do is just looking at your vertex form, you should know that the vertex is -5, -8. And that's exactly where I have it drawn, so I know I'm on the right track. Okay, now for your domain, why don't you pause the video and see if you can get this correct. So pause it and then come back. So your domain should be x is an element of all real numbers because it can be anything. And here for the range, y should be greater than or equal to -8 because nothing is occurring below this -8 value on your grid. Everything is above it because the parabola opens up. All right, one more example here. So once again, I want you to pause the video. We have 2 transformations here, and be very careful with your a value. And then graph your parent parabola. And then come back just to check your work before you start transforming it. Okay, so for your transformations, hopefully you have a vertical stretch by a factor of 5/2. And maybe you want to make a note for yourself that 5/2 is the same as 2.5 for when you actually stretch it. And then you're going to shift to the right 2 units. So let's go ahead and try that out. So using your parent parabola, I want you to multiply all of those y values by 2.5 to see where they end up when it's stretched. So pause the video and then come back. Okay, so the vertex stays where it is. The points that are at 1, when I multiply it by 2.5, I get 2.5, so I just move them there. Still the same x coordinates though. Points that were at 4, when you multiply them by 2.5, you get 10, so I stretch them up there. And then the ones that are at 9, they're off the page. And then I label this as y equals 5/2 x squared. And now you can shift everything to the right 2 units. So again, pause the video, do the shifting, try the domain and range, and then come back to check your work. All right, so once you've shifted your parabola, there should be some overlap, but there it is. Your domain should be x is an element of all real numbers, and for your range, y should be greater than or equal to 0 because your parabola is opening up and the minimum value is 0. So there it is. When you're graphing, state your transformations, graph that parent parabola, which is always the same, do your a value in 1 or 2 steps depending on the process, and then again, your shift 1 or 2 steps, whatever you like. But I do need to see intermediate steps when I want you to graph using the specific transformations.